Hello and welcome to the next RLabs video on combining data. Today we're going to learn about how to bring data together, and the first step in doing this is to explore the data that we have to work out how we need to approach combining it. To do this you can use many simple functions like summary, class, plot and many others. Once you know precisely the type and format of the data you have, you can then try and mash it together and combine it. This is quite easy to do if the data is nice and clean and tidy and has the same format, in which case if you're wanting to combine columns together you'd use just the cbind function, and if you're wanting to add more data, add more rows to existing datasets, use the rbind function. If though the data is formatted differently and the rows are jumbled up, you may find it useful to try and combine data using the merge function. Today we're going to be working with data from Dr. Fly Knightley, who is an ecologist passionate about owls. She has several separate data sets on owls, and she's wanting to combine them together to try and ask questions about morphology, ecology, and the evolution of owls' traits. The three datasets she has are owls morphometrics, owl clutch size, and owl lifespan. Here's a view of some of this data that we have. On the left here we have owl morphometrics. On the right we have owl clutch size. You can see that they both share some columns. So here we have common name in our first dataset and common name in our second dataset. And you can see that they line up nicely. So we've got our first row in the first data set is barn owl, and that corresponds to the clutch size data set as well. And it goes down. It's nice and ordered, it's formatted in the same way, common name is sorted alphabetically, and there's the same 14 species. To combine these, you just have to stick them together. A more complicated example of combining data together can be seen when Dr. Fly Knightley tries to combine owl morphometrics and owl lifespan data. For the first dataset, for owl morphology, you can see that common name is sorted alphabetically, whereas for the lifespan data, it is jumbled up. Because of this difference in format, we can't simply add the two datasets together. We have to do something more. We have to be able to let the computer know which rows in dataset A correspond to which rows in dataset B. First, let's go to RStudio. Let's set a working directory where we've saved 3 files. Now let's try and read the first file. You can see that our morphology dataset has been read in. Now let's explore the data, summarize it. This is good. We can view the data. There's no NAs, we're very happy. In this opening stage, just after we've read the data, I've got into the habit of going through my variables and classifying them as factors if they are categorical variables. It's a good thing to start doing. So we can classify common name as a factor, and the same with Latin name. Let's maybe plot and explore some of this data. So we can plot weight against wingspan. We see this nicely, and there's a clear non-linear relationship between weight and wingspan. Dr. Fly Knightley already knew about this interesting non-linear relationship between weight and wingspan, but she's now interested in exploring new trends to see if morphology can explain behaviours like clutch size or the evolution of lifespan. To do this, we have to now combine datasets. Using the read.csv function, now let's import one of our second datasets, the owl clutch size. Let's inspect this data. Again, this is looking good. There's no NAs. We note that common name is a shared variable with our previous data set, the owl morphology, and the data within common names is in the same order between the clutch size data and the morphology data. Because of this similar formatting and the consistent arrangement of rows between datasets, it's easy to combine these simply using the cbind function. In our case, it takes the two data frames and combines them together, adding the columns of the first dataset and the columns of the second dataset together. We've assigned this to a new dataset called owl.morphology.clutch, and let's just check that the thing we've outputted is in fact a data frame. To do this, we use the class function, and yes, indeed, it's correct, it's outputted a data frame. Let's go ahead and inspect this data frame that we've now created. It's looking good, but we will note that there is a duplication. There is two columns where we have common name. To improve on this and remove the duplication of the common name column, let's perform again the cbind function, but this time only call a portion, a subset of the clutch size dataset. To do this, let's overwrite the data that we've just produced with a more appropriate call. This time, instead of giving the cbind function both datasets in their entirety, we can give the whole dataset of owl morphology and just a portion of the owl.clutch.size dataset. Here, we ask it just to include and combine with the owl morphology dataset just the second column, the data on clutch size, therefore leaving out the duplication of common name. Let's inspect this data. Wow, yes, we've done it. We've removed the duplication of common.name. It only occurs as one column now, but we've run into another problem where where the owl clutch size data has got a very uninformative name, so we may want to adjust for that now and give it a more meaningful, interesting name. To do this for a data frame, we can use the colNames function, and we can override its previous name with a new, more transparent name, clutch.size. And yes, this has worked correctly. So we've now combined for Dr. Fly-Nightly data on owls morphology with their clutch size. So let's go ahead and plot this and look at and inspect to see whether there's some sort of relationship. Interesting graph, not sure if there's a relationship. Moving on, we have the third dataset that Dr. Fly-Nightly wants us to combine with the previous ones. Data on owl's lifespan. Again, we use the read.csv function to import the data. We'll inspect it, and we're going to note a few things. We're going to note that yes, there's an NA for one of our values, so that there was no data present for the northern pygmy owl. And unlike the previous example, now the data in the column name rows are mishmashed and are in no particular order. This means we can't merely combine and sandwich together it with our previous data. We need to tell R exactly which rows from this dataset on lifespan match up to the rows in our previous dataset. To do this, we can use the merge function. Again, it takes in two data frames. Our data frame that we've produced, which has both morphology and clutch size, and the new dataset that we've just read in on our lifespan. It then has a parameter called key, and this tells R that we want to arrange our data by common name. So this is what we've got for barn owl row 1. Let's just jump back to the original datasets that we read in, just to double check that combining these data has been done correctly. Barn owl, yes, it has a wingspan value of 110, and if we look at lifespan, find barn owl down here, a value of 17. We could maybe check a few more, but I'm happy that this has seemed to have worked adequately. Dr. Fly-Nightly is very happy. we've combined the data together using several functions like cbind and merge. We've now got the dataset in one master data frame that allows us to easily and simply plot and do statistical tests. I'm sure Dr. Fly Knightley is going to have many interesting days ahead analysing this data. Thank you for listening to this R-Labs tutorial video. If you found this useful, you may be interested in our free online Moodle course, or check out and subscribe to our YouTube channel.